Providing practical management solutions is what the Soil Quality website is meant to help provide. In WA, correcting soil pH is the classic case.
A lot of our soils are very acidic, and the research has been going on now quite a long time, probably 20 or 30 years, but there's very good evidence that by liming, although you may only see very small annual incremental increases, it actually pays off about over an 8 to 10 year period. So it's economically viable to be liming to remove that chemical constraint and therefore improve production. It's very easy to make that illustration directly to the pathogenic or the disease side of soil biology. So if you remove pathogens that aren't affecting your roots, you'll get an increase in production. Where it's harder to make that direct analogy through to production is with some of the beneficial sides of soil biology, because it's not quite a one-to-one relationship. So for example, if you have a healthy soil biology that's breaking down a lot of organic matter, releasing nutrients, that may provide an additional nitrogen benefit through to the crop, but it's an indirect one through nutrient supply. So they're a little bit harder to illustrate and trace back, and part of the reason we run workshops is to explain those connections through, because they're not a one-to-one relationship.
WA's web platform is being used as a framework for the national rollout of soilquality.org.au. This gathering of state representatives was to see how the WA model could be modified to best fit each state's needs. It's anticipated all states will be online by the end of 2012. The soil data that will be needed to load the website will come with the help of grower cooperation, especially grower groups. Grower groups tend to represent climatic regions, key soil types, land uses and management practices. Even regional boundaries won't limit the diversity of the soil biology, so a rigorous sampling protocol is used.
So what we're doing at the moment, for example, is for every soil by land use combination, we actually need 25 representative sites to allow us to really get a good understanding of what those values are. So there's a very large soil sampling component. We're looking at the top 30 centimetres of soil, and that's looking at a 0 to 10, 10 to 20 and 20 to 30 centimetre layer. And the reason for that really is that it ties in very nicely with the current interest in carbon storage and carbon sequestration. And really, as the government is looking at a 30 centimetre depth for that, it ties in nicely having carbon values down to 30 centimetres as well. So there's an added benefit there to using those depths.
The soil sampling technique is just as exacting.
We're working on a monitoring grid, so we're working on a 25 by 25 metre area. Now if you think about that on a paddock scale, that's quite a small area, but the key for us is it allows us a site that we can return to. So it's a geo-reference site that's very well characterised, and we can go back there through time to see change. If you start trying to sample over a larger area for what we're doing, then the spatial variability just really knocks you, and it's very hard to go back and sample change through time. And this is about looking at dynamic indicators and really getting an understanding of how we're changing. Is it up? Is it good? Are we staying status quo? Or are we declining and really need to identify some management options to intervene?
Soil samples taken from around the country will go to key laboratories for processing. In WA, the biological indicators are assessed. In Adelaide, some of the phosphorus analysis is being done, and the molecular work is also being spread around the nation. It takes 6 months for the soil samples taken from the paddock to be analysed and the data made available on the website. In each case, a soil quality champion will take ownership of the soil collection and data delivery process. Tasmania has been running its own soil quality program for 7 years, and Bill Cotching is that state's champion.
I think I've got to be a face to the farmer focus for this information, which really is how I see this project being.
While the Tasmanian project covers 300 sites and already links its data into CSIRO's Australian Soil Resource Information System, to be part of the National Soil Quality Monitoring Database has practical relevance.
It allows us to put ourselves in the national context. So, for instance, if we're reporting for state of environment reports, how does Tasmania sit? Well, these sorts of national projects allow us to do that. If we do our own thing just as Tasmania or any other state, we don't get that national sense of how we're tracking as a nation. And I think the national reporting is just as important.
There's no point collecting the data if it's not going to be used, so it's a very central component to it. The idea really is that instead of just talking to growers about management and about soil quality, the key point with the way this project works is we have our own data. So there was data generated farmers have paddock information, they can see the numbers, they know exactly where they're benchmarked, and all that has to be extended back to the growers. So that's extended back by giving them their own data. So if you own a paddock, you get your own data, but they can also see that data aggregated up for a group or for a region. So they can start to see how they fit into a bigger picture as well. And the website and the extension program has a number of ways of interpreting data. So we can just give you back your numbers, but we can also show you where you're sitting or benchmarking against the peers in your area, and how you're benchmarking against what we call a traffic light system or critical values, where expert panels have actually worked through what they believe are the key points for each indicator where change is being identified as being good or detrimental.
The traffic light system was chosen as a simple guide to help growers make practical decisions.
Exactly. So if you saw where you sat on that traffic light system and, for example, it said that your pH was too low, then you could follow that through with fact sheets if you needed to know more about it. But in the case of pH, which is a good one, you could also follow that through with an economic calculator on the website that gave you some ideas about the sort of cost that might be involved in liming and the sort of benefit associated with that. So it's no point identifying problems that can't be fixed. It may be very useful to be aware of those, but we're really after where can we identify constraints and then allow growers to change management to improve their soil status and therefore not lose productivity.
On the soil quality website, this is how the traffic light for pH would appear.
If you're in this 5.5 to 7.5 region, you're doing okay. Keep monitoring it. If you're in the orange region, you might be having some production impacts. It's worth investigating long-term management of that. And if you're in the red region, obviously you're in an area that's almost definitely having a production impact.
Soilquality.org.au will provide data, prompt action, and get growers thinking about nurturing microbes as well as crops.
That's right. I mean, I once said previously when I was in WA at a forum on soil quality about 4 or 5 years ago, I said there's a party going on down there in the soil, and one of the other scientists said that he felt it was more of a war or a battle between the good and the bad factions. So you can look at it either way. If whatever's happening in that soil, you have to feed it, you have to give it energy too. So it's not just food. The fertilisers that they're putting on, growers are putting on, the fertilisers are feeding both the soil organisms and also the plants, but also the energy that you need to put in terms of residues that you retain, and the quality of those residues in terms of do they come from cereals or do they come from other components of the rotation crops. So we hope through the soil quality website that we will give them the tools to be able to make decisions that will help them really manage their soil biota and really for the benefit of their system, the economic benefit ultimately of their system.
The extension aspect of the soil quality monitoring project will go beyond the internet interface. The Soil Quality Champions will help organise face-to-face sessions between growers, researchers and specialists.
Not everyone likes to use websites, so we also like to run on-ground workshops. So the workshops, the soil quality workshops, will focus around a component of delivering back the data and explaining what the data is. But what we tend to do with those workshops is look through the data and see what the key issues are and make sure that specialists that have regional knowledge come into those workshops and actually talk to the growers about some of their options. So it's not only scientists in these workshops, we would bring in local agribusiness, local agronomists that work with groups that have the on-ground knowledge and try to really help that group work together with coming up with some solutions. Now that might end up with the group, for example, then going off and running a trial on one of the farms, and they might do a test case before they implement a management strategy.
Whether the data will be extended to the farming community via the internet or grower groups, its application will be the same.
Farmers can use this information in a number of ways. I think they will be able to use it as a reinforcement that the management regimes they're currently using are good and that they are benefiting the microbial community and enabling that microbial community to perform the functions that are ultimately beneficial for plant production. But I think in the longer term, through particularly the sequencing technologies, we will be able to identify novel species of organisms that might be then developed into products, inoculant products that farmers could then go and use. So There's quite a bit of work in this initiative and in previous initiatives which is really interested in developing novel inoculants, say for biocontrol and for accessing phosphorus, so phosphorus solubilising organisms.
There's international interest in the practical focus of Australia's soil quality monitoring project, and the framework is being considered for use in the United Kingdom.
The website that's been developed here is really interesting because what it does is it takes data real time. It doesn't just show you static web pages, it's drawing graphs with real data all the time and giving pictures to farmers of what's actually happening and how their data relates to that of other farmers. And that's just really exciting, whether you're in the UK or in Australia.
There are plans in the future, and it won't happen for the next couple of years, but for there to be an English version of the soil quality website, which would be a great thing to extend something back into Europe.
Measuring the implications this soil quality monitoring project will have is pretty much impossible. Like the human genome work, the opening up of the soil biological black box is certain to produce countless invaluable insights and commercial opportunities. At the least, it will change how farmers look at the soil and what management decisions they make.
Trying to improve soil productivity by managing the biology, I think is going to be critical for farming systems, because otherwise the cost will continue to go up and we just won't be viable.